Good afternoon, everyone. Today we have my friend and colleague, Dr. Javier García-Planells, who's going to talk about genomics precision diagnostic. Javier, whenever you want, the floor is yours.
Thank you very much. I'm going to talk about a particular unit in genomics. It's called genomic precision diagnostic, and it's focused on the genetic diagnosis of patients. The genetic diagnosis is the process by we try to identify or rule out a molecular cause of a disease with the idea to obtain the diagnosis of a patient, of an affected patient, or people who has a high risk to develop a disease. This is, in some cases, the first step to provide another genetic testing for reproduction. For example, PGTM or prenatal testing. Reproductive genetics are focused mainly in inherited diseases, monogenic diseases, but we have a lot of different types of genetics applications. We need to take into account that genetic diseases, approximately 40% of the patient, they don't receive a good diagnosis, they obtain a misdiagnosis during their lives. These generate a lot of medical appointments during their life and more than 5 years to get a correct diagnosis. This is a problem because many of these patients are involved in a diagnostic odyssey to try to identify the genetic cause of their disease and enabling the possibility to have access to other reproductive testing. One of the focus of GPDX is to try to shorten this diagnostic odyssey. This is an important question because genetic disorders are, most of them are called rare diseases because the prevalence and the frequency of all of them are very low. But if we take that into account, if we take all together, we know more than 70,000 rare diseases, and this poses 80% of the population. For example, in the world, we have more than 400 million of people affected for a genetic disease. The objective of the genetic diagnosis is, the first one is to obtain the accurate diagnosis for the patient, to know what is the name of the disorder, to establish this diagnosis, provide information about the prognosis of the disease, and to provide the access to an increased number of treatments, therapeutic action, or clinical trials. In reproductive genetics is very important because it's the only way to start with the cascade family testing and to have the opportunity to enable to provide the possibility to access to PGTM testing or prenatal testing. The genetic diagnostic precision provide opportunities to provide genetic testing to all the stages of the life, not only the preconception, pre-implantation, and prenatal stages, in all the different stages, obtaining this accurate diagnosis for children, for parents, and all the closing the circle of the reproductive journey. We have different types of genetic testing for the different stages of the life, and we have also taken that into consideration that we know that we have different types of genetic causes and molecular causes of different diseases. For example, the typical are the classical cytogenetics, provide information about the alterations of the chromosomes. We can obtain information about the structure of the numeric alteration of the disorders, but also the molecular genetics provide information for many other type of mutation, point mutation, insertion deletions, or mutation specific in gene or exon. In this case, the analysis should be very specific because we in the human genome we have more than 300 million of nucleotides and positions that could have mutated and developed a disease. For this reason, in Igenomix we have developed a very wide portfolio, different types of technologies that should be used depending on the clinical question of the patient. For that, we are very committed with the support of our clinicians to provide a different slice of support from the genetic counselor, genetic scientific advisor, clinical director, and board to provide and to help to the clinician to take the best decision about the technology to optimize the decision making of the patients. And at the end, the model is this one. with a management of the clinical data, because as I said, we have more than 3,300 million positions that we have to read. It's very important, the technology, but it's probably at this moment more important this data, this management of the knowledge, at the end to provide a concrete report to the patient and a concrete report to the clinician to provide information to the patients. For example, in prenatal diagnosis, we offer different types of technologies, the karyotype, the classic karyotype, chromosomal microarray, but also disorder, specific test for single gene or exome disorders, depending on the clinical case and depending on the situation of the case. For example, here I present a clinical case of a pregnancy with a suspicion of problems with kidney diseases. We have created a specific panel analyzing a lot of genes different with a platform that we have developed in-house, and we can find the genetic cause of the disease and provide information about this family, because in this case it's a recessive disorder. We have identified the same mutation in both parents are carriers, and this enables also the possibility to analyze this type of mutation in other members of the family and to have access to reproductive technology and reproductive tests. Regarding to the neonatal, in this case, approximately 3–4% of the newborns born with a genetic disorder. The early diagnosis is very important to have access to the treatment, but also for to have access to the couple and the family to give genetic tests and reproductive level. In this case, it's a case of a newborn that has born with a 𝗚𝗲𝗰𝗀. The suspicion is spinal muscular atrophy. We have detected the deletion responsible of this disorder, and we have identified the mutation. In this case, this disease is very important because the carrier rate is very high. It's 1 per 40 or 50 people, and the probability that the family has another mutation is very high. And also in postnatal, approximately 6–8% of the people has a genetic disorder. The early diagnostic is very important to shorten the diagnostic odyssey and to have access also to reproductive testing. In this case, it's a 5-year-old boy with suspicion of Duchenne muscular dystrophy. We have identified the mutation. We have analyzed the mother. The mother is a carrier of the disease, and with this information, we have this picture in which there are many females in the family that probably are a carrier, and they have access to they could have access to the reproductive testing. And that's all. Thank you very much for your attention.